Hello, in this video I will explain to you about the projectile motion. Basically, projectile motion is combination between vertical motion and horizontal motion. So, if you want to solve a problem about the projectile motion, you must search or calculate the component x and y. X for the horizontal motion and y is for the vertical motion. If we have here the angle of the object throw, yeah, and then we can search between the x component and y component, yeah. So if this is initial force, we will have initial force in x component and x-axis and initial force at y-axis. So if we already know the angle, we can just calculate the x component with initial initial velocity times cos theta. Okay. And for initial velocity in y-axis, we can use initial velocity times sin theta. Okay. So we just have one formula for motion with constant velocity. Is it s or x or delta x equal with v times time, yeah, v times time. And because its motion is constant velocity, so that means the velocity or v always equal with the initial velocity. So that means if we want to search the distance, we can just use this formula. Okay, this. And next, the vertical motion is accelerated motion. So we will have three formula from accelerated motion that I have mentioned it in last video. Yeah. So we have v velocity equal with, because this is the velocity of y, so that means we just add y in here, and this is just we add x. Okay. Initial velocity y plus, because usually actually the formula is accelerated times time, but we can change it to acceleration, gravity acceleration. Okay, and then we will have, instead of x equal x0 plus initial velocity y times time plus half times g times t square, because is it vertical motion, so we change the x or the distance into height. This is the initial height, and the last formula is yeah. And just for the note that in vertical motion, velocity in y velocity is always zero at highest point. Okay. Okay, then this is the example for projectile motion. Yeah. So an arrow is fired at 30 degree up to the horizontal with an initial velocity of 24 meter per second. Calculate A, highest point that arrow reached, the maximum distance before the arrow land on the ground, and the position of the arrow when it's 2 seconds. Okay, so first of all, we need to search the x component and y component. Yeah, we just draw the arrow in here. Okay, so the arrow is at the velocity or initial velocity is 24 meter per second, and it has 30 degree to the horizontal. Okay, so that's mean we will have initial velocity x and initial velocity y. Okay, even though the question didn't ask us to search or calculate them, but we need to calculate it first. Okay, so initial velocity for x component is 24 times half square root 3. Okay, so we'll just have this one. Okay, and for y component, so the y component is 12 meter per second and x component is 12 square root of 3. Okay, and then we can answer the A question. Yeah. Okay, so A question, highest point that arrow reach. So in highest point, we already know that the velocity or y velocity is 0. Yeah, because it's in highest point or in peak point. Okay, so we already knew that g equal with 10 meter per second square, and then we just need to use the formula. Okay, so because we have y velocity and initial velocity and then g, and we have to know that the highest point. Yeah, so we can use this formula. And we already know that we can assume that the arrow is fired on the ground. Yeah, so initial height is 0 meter. Then we can input the data. This one is 12. this one 2, and don't forget about the negative one because the direction is down, and H here. So we got we can move it to this one. So the height or maximum height is 144 per 5. It's equal 28.8 meter. This is for the A question. Okay. For B question, the maximum distance before the arrow lands on the ground. So that means we need to know the time flight of the arrow. And the time flight of the arrow, if we see the projectile motion, it's always 2 times of time that needed to reach the highest point. Okay, so that means we can search the time to highest point first, and then we will know the time flight. Okay, so in order to know the time to the highest point, we can use the data that on top or highest point is y velocity equal with 0, and the initial velocity of component y is 12 meter per second, and then the gravity is 10 meter per second square. And remember to give the negative sign to gravity acceleration, and we can use the formula y velocity equal initial velocity plus gravity acceleration times time. Okay, and then this one is 0. This one is time to height, maximum height. Okay, and then we'll get 10 t maximum height 12. So that means time to reach the maximum height is 12 per 10 equal with 1.2 second. And then we'll move to here. So the time flight is 2 times time to reach maximum height, and 2 times 1.2 second equal with 2.4 second. And the maximum distance, it means the motion is in horizontal. So we will use the formula, this formula. The x velocity is always equal with initial velocity. So that means this one is 12 times 2.4. So the total is 28.8 square 3 meters. This is the answer for the question. Next is for question C. The position of the arrow when it's 2 seconds. That means we need to calculate the height and the distance from the starting point. Okay. So if we know that this is the starting point and the projectile move like this, and then in 2 seconds How about the height? And how about the distance? Okay, so that means we will search it. Okay, first of all, we will calculate the distance. Distance equal with x velocity times time. So that means the distance from the starting point is meters. And then for the height is y initial velocity times time plus half times gravity acceleration times time square. And then this one is 12 time is 2 seconds plus half. Remember, the gravity is always minus 10 meter per second square times 2 square. Then we will cut 24 plus negative 5 times 4 equal with 24 minus 20. So the height is 4 meter. So the position of arrow the time is equal with 2 seconds. R 4 meter. The distance is 24 square 3 meter from starting point and the height is 4 meter from the surface of the ground. Okay, that's it. Goodbye.